Hello, we are continuing our cardiovascular system unit, and right now we are on cardiac cycle and EKGs. Belle, one of my four cats, has decided that she would like to accompany me when making this video. So I guess she's just going to hang out on my shoulder. So we'll see how long she lasts. All right, so the cardiac cycle. Cycle lasts about zero point 0.8 seconds, so less than 1 second. Well, she's gone. The cardiac cycle is all of the events in one singular heartbeat, okay? And it needs to be controlled and rhythmic, okay? So we have to control the speed and we have to control the rhythm. Either one of those is out of sync and the heart's not going to be efficient. It's not going to pump, either it's not going to pump fast enough, it's going to pump too fast, or it's not going to have control and it's going to pump ineffectively. So there are two main parts to the cardiac cycle which determine the rhythm and speed of the heartbeat. So first would be the electrical event, and that's going to come from the nervous system, and that's what's going to allow for the impulse to be sent for the heart to start contracting. And what follows the electrical event is the muscular event, and the muscular event is the contraction of the ventricles. So there are two terms to know for that. There's systole, that means contraction, and the second term is diastole, which is relaxation. Okay, so cardiac cycle, 0.8 seconds, two parts. First, electrical, boom, signal. Okay, second, muscular contraction. Okay, so those are the parts of the cardiac cycle, and the whole thing from beginning to end lasts less than a second. Okay, now we'll talk about the conduction system. All right, so remember that's the electrical event, so this is related to that. This is how that electrical event actually happens, and it happens in 4 stages. Okay, first is the SA node or the sinoatrial node. It's the pacemaker of the heart. Think of it like the drum beat in a song. Sets the rhythm, sets the pace. That's the SA node. Pace, SA, pace, SA. So the sinoatrial node or SA node sets the pace. It's the pacemaker of the heart and it begins the contraction. So it's going to begin the cardiac cycle. Okay, and then the signal goes from the SA node. Now the SA node is up in the right atrium and it's going to go to the AV node. Now the AV node or atrioventricular node is at the border between the right atrium and the right ventricle. And it delays the signal a little bit just to allow the atria to finish contracting. So it's like, oh, hold up. Okay, go. All right. So SA node sends the signal to the AV node. AV node, oh, okay. Now the AV node sends the signal down the bundle of His, which is the AV bundle in branches, and it goes down the septum. Okay. And then once it goes down the septum, the signal goes through all these Purkinje fibers. Purkinje. All right. So what's the point of the Purkinje fibers? Well, I want all of the muscle cells in the ventricle to contract at once. If this section contracts first and then this section and then this section and then this section, well, the contraction is going to be inefficient. Right? So I need an efficient contraction in the ventricle. So I need all of those cells to contract together at once in a coordinated contraction. So that's what the Purkinje fibers do. All right, so let's talk about depolarization and repolarization. Depolarization is the process which positive ions rush into the cell. So let's look at right here. So here you can see it. Here is depolarization. Okay, depolarization is when we have positive ions rushing in, okay, into the cell. So positive ions whoosh, flood in, cause a contraction. Depolarization, decontraction, depolarization. All right, so positive ions whoosh, rush in. Okay, but that muscle cell will not be able to contract again unless we get those ions out. So this right here is repolarization. So that means the positive ions are going to be pushed out, okay, so that the muscle cell can be ready for the next contraction. So repolarization, release, get ready, okay, the positive ions go out. So depolarization in, repolarization out, depolarization in, repolarization out. All about the movement of the positive ions. So here you can see what's happening to the charge, right? Going from very negative to positive and then back down to negative. And the cell unfortunately overshoots it a little bit, but then it stabilizes, okay? All right, so here's the whole system again, so let's talk about it, all right? Electrical event, SA node. See it up there in the right atrium? AV node, stop, bundle of His, Purkinje fibers. SA node, AV node, bundle of His, Purkinje fibers. Okay, that's the cardiac cycle, the electrical event. Okay, the muscular event is that contraction. Okay, so an echocardiogram. All right, an echocardiogram is a sonogram, an ultrasound of the heart. Okay, it allows doctors, technicians, nurses to monitor the muscular event of the cardiac cycle. In addition, you can sort of see it in this little clip here. You can see those valves flopping, open and close. It allows the opening and closing of the valves to be seen. So echocardiogram uses sound waves and it allows monitoring of the muscular event plus the opening and closing of valves. An electrocardiogram sounds like electricity, right? It's also called an EKG or ECG, and it is recording the electrical event, okay? Not the muscular event, the electrical event, what happens first, okay? So it allows the whole monitoring of that SA node, AV node, bundle of His, Purkinje fibers, as it relates to the contraction. So let's look at what we have here. So this little first blip right here, blip, that is a P wave. There's the next one, okay? P wave, all right? So I'll label this one P. So P wave. P wave is the first little blip. That's SA node to maybe where the AV node is. Okay, so SA node is that allowing the whole contraction of the atria, okay? Then we have the QRS wave. So that's going to be up here. So this whole big thing, this high blip, and here's the next one. So QRS, notice how much bigger it is. The ventricles contracting is a much bigger deal than the atria contracting. So little blip, P wave, big blip, QRS wave, and then we have finally right here, we have the T wave. So over here, there's where it was. So in the T wave is when the ventricles are repolarizing. So remember that's pushing those positive ions back out, okay, getting ready for the next contraction. So P wave, QRS wave, T wave. Here you can see again, P wave, QRS wave, T wave. And the whole thing is a cardiac cycle, okay? Here's what it looks like. EKG, you have lots of leads attached to your body. Monitor what is happening to your heart. So you can see what's happening in the P wave, right? AV, SA node to AV node. And then you have the QRS wave. You can see down the bundle of His to the Purkinje fibers. And then we're going to have relaxation and depolarization and repolarization in the T wave. Okay. So a stress test, what happens in a stress test? Well, you're going to be hooked up to an EKG and you're going to exercise. And the reason doctors do this is to test the effect of stress, and not necessarily stress meaning, tell you all the things you have to do and all the things you haven't done, try to stress you out that way, but stress your heart physically with exercise on a treadmill and see how your heart responds. And it's often done to determine readiness for surgery. Okay, so here's a normal EKG. So you can see a clear P wave, QRS wave, T wave. Light pause, P wave, QRS wave, T wave, and the cycle continues. And notice they're about the same distance apart, okay? They're about the same height, all right? It's pretty consistent. If you have tachycardia, tachycardia is a rapid heart rate. So a heart rate above 100 beats per minute, you can see these waves are kind of scrunched together. You still have a P, a QRS, and a T wave, but there's barely any space between them. Opposite would be bradycardia, where you have a low heart rate, so under 60 beats per minute. Instead, you can see you still have a P wave, a QRS wave, and a T wave, but there's all this empty space in between, too long of a pause. Okay, then you can have arrhythmia. So technically, bradycardia and tachycardia are arrhythmias, but this is just a general arrhythmia. So you can see there's irregular spacing. So here I have, so right here, look, here's the distance between T and P. That's fairly consistent. And then all of a sudden here, look, I have this distance, and then here. Okay, so the distance between the end of the T wave and the beginning of the P wave is inconsistent. Then we have asystole. Nothing. No P wave, no QRS wave, no T wave. No electrical activity in the heart. That's called a flat line. Atrial fibrillation. So look, it sort of looks like a normal QR, but not really. It doesn't, the QRS, it doesn't go down at the bottom. And then you have just this sawtooth, zigzag-ish, irregular pattern between these abnormally even looking QRS waves. Okay, that's atrial fibrillation. So the atria are acting weird. The ventricles are trying to contract normally, but the atria are all over the place. In VFib, which is ventricular fibrillation, it's a mess. Like there's this whole irregularity. This literally will lead to death if it's not resolved. Okay, because there's no rhyme or reason. The ventricles are just all over the place and contracting irregularly. There are a lot of other abnormal EKGs. I was just focusing on a few of them that are relatively easy to differentiate between to just make it a little easier. And there you have it. That's the cardiac cycle, 0.8 seconds. Electrical event, muscular event, SA, AV, bundle of His, Purkinje fibers. Okay? And then the echocardiogram, seeing the muscular event and the valves, and the electrocardiogram, seeing the electrical event. There you have it. Hope you learned something, and there will be more coming.